Hello everyone and welcome back to another episode of C# programming tutorial. Today we are going to talk about the threads in C#. So first, what is a thread? A thread is defined as execution path of a program. Each thread defines a unique flow of control. So how to define a thread in C#? It's easy. You just need to come here and create a variable. Let's call it thread and new here thread. For input, you must define a function to pass it in. We've learned about the delegations and functions. If you don't know about it, please check out our video. Now the function should be like static void start thread, and here I will take it and put it here. It's one way. The other way is to put a object here and obj. So this way we can pass an object into it. Now there's another way by defining a delegation or using the action delegation, which we have learned in previous video. Here I will write a lambda function, and then here we can write our code here, and also we can put an object here, object. And to check this part is running asynchronously, we shall write some code here to see console.writeLine. Now here I'm in thread, let's say thread 1. Let me write thread. Let's sleep for a second. Now let's start another thread here, thread 2, thread 1. I'm in thread 2, and here while through the same thing here I'm in main thread here while true, and putting it here. The same can go for here, thread 1. And let's add a waiting here so we can see what is going on. I'm in the main thread, in the main thread, in the main thread. You see, we can't see that I'm in the thread 1 or in the thread 2. The reason is that because we didn't start these threads. For thread 1, we shall write thread 1.start, and because we have an object here, we shall pass an object here, new object, for example, oops. And this is the parameter that we have passed it there. And for thread 2, we can simply start it this way. So let's just start our application one more time. As you can see, everybody's running on their own. Now let's change the timing of these threads. I say it should be about 500 milliseconds. And now let's run it again. See, 1 is echoing very faster. Now let's increase this part for 5,000 milliseconds, which also means 5 seconds. This is the result. Well, I believe you got the point. Now you might say, well, what this object is worth for. This object is worth for sharing data between our threads. Now let's assume that we have a class here, class data, and in our class we have a number. Now in here I want to write variable data, new data. Yep, that's it. And putting data here, and also putting data here. And then in here, I will cast the object to data. Here, and data, also object. And data in here should be increased, data.number ++. And that's it. Again, here we shall put the data casting here, also adding object here, and putting this one, the number is dot number. I'm putting a $sign here. Now let's set for a 1.5 second for this thread, and let's just start it. It's 1, 1, 2, because the thread 1 was running. 3, you see? We could just share the data between two threads, which is dangerous. Now here comes how to share data properly to stop ruining our data between 2 or 3 threads. Why do I say it's dangerous? Because when you share data between 2 threads, there are some sickness in this way. Things like starvation or stuff like that, which you can search online for these terms. To stop them, we are going to use some other dangerous things to use. You should be always careful when you're doing multi-threading, and the dangerous thing that is going to protect you from the dangers of this sharing data is lock and semaphore. So I've prepared a use case to see how bad can it be when you share data. Let me remove this part. Now let's write service use case that example 3. Now let's run our application. 1, 1, 2, 3. Why 2 or 1? Well, let's see the example. This is our example. I've created an abstraction for our threading to make it more robust and efficient. Now here I created a service. Each service represents a thread. I created a service and shared a data called number. Here we have a number that is shared between 2 threads, thread service 1 and thread service 2, which both just got started here. And then there was a sleep for about 2 milliseconds, and then pause the threads, and then sleeping for 10 milliseconds to finish their job, and then stopping those threads. You see here, it was 0. We were supposed to see one of them 10, the other one to be 2, and then the other one 3, and then the other one 4. But it didn't happen. I can run it for one more time to see how the result goes. See, 2, 2, 3, 4. It's like a random number generating thing. We're not seeing that it's going one after each other in order, but it's more like a random number. So how to stop it? We have created an example 2. Let's run the example 2 first. Example 2, run it. 1, 2, 3, 4. If I run it one more time, you see the exact same result. The reason is that in example 2, we used something called lock. We lock our data usage here. See? In here, I started a lock scope and passed an object. This object is shared between 2 services. Maybe the best could be that I lock on the number, but a number is a primitive type and I cannot make any lock on it. So I create an object and I created the lock on that object, and then I wrote anything that I wanted to write here. So whenever I run this, when the execution code, for example, comes to here, to this line, if in here we were at this line, then the other execution pointer will stop at here until this block of code ends, and then the other one will get into it and will come here and then run here and then run here. If this one was just going to repeat again, we'll stop at this one until this guy finishes his job. And that's all about the lock. And you're going to use a shared data between multiple threads. So let's talk a little bit more about our service that I've built here. Using threads is almost always sometimes a hard task for developers because there are a lot of boilerplate code. But as you can see here, we've removed those boilerplate codes, and we've added some functionalities like pause and resume. I can show you here the example 1, which you can see we created a periodic service which will run on every second. It will do his job, then he will calculate how much left to wait, and then we'll wait for that much of time, and then we'll continue to do this block of code again. So now let's run this example 1 first. Now first let's start our for example 1. Going to started, some seconds passed, then paused, nothing happens, then resumed, then it's counting, and now it's stopped. Very controlled. I put the source code on my Patreon. If you want to support me and receive the source code, go ahead. Thank you. Leave a like if you like this video and subscribe to my channel and hit the bell so you will be notified once I publish my next video. Thank you.